Hi, this is a little bonus video from the video I created yesterday, where I talked about 6 GHz discovery mechanisms like fills, broadcast probe response, and reduced neighbor report. So let's talk a little bit about preferred scanning channels and reduced neighbor report. Preferred scanning channels was made to help the clients who didn't have to scan every single 59 channels. So it's a set of channels where they can scan or probe. But as we know, by using reduced neighbor report, we can get information about the 6 GHz network that you have. If you have like a network that is 6 GHz only, you will get information by having any other SSID on your controller, just any other. Have a guest network on 2.4 GHz that can contain information about your other 6 GHz network inside the reduced neighbor report. What I saw by using Meraki and Cisco was that when you use channel 1, a non-preferred scanning channel on Cisco, you get a beacon on channel 1. That's okay. When you do the same or set on a non-preferred preferred scanning channel on the Meraki, you get a beacon on channel 1 and channel 5 at the same time from the same radio. So the radios, it can send it's the exact same beacon. I took a capture of it. Just thinks that's weird. Why would you do that when we know that reduced neighbor report works so fine? I have many other SSIDs configured on this Meraki lab. So let's just see that real quick in the Aronia RTSA Suite Pro so we can see what is happening. Okay, so here we have just a combo view. It's just a very easy mission. I wanted to see this live. So I'm gonna start playing it, and we see there's nothing happening right now. What I'm gonna do first, I'm gonna enable the SSID on my 98-100 controller there. And what you would see soon would be beaconing on channel 1. Like, that makes sense. So I can make this go a little bit faster. I can stop it. Okay, maybe take it 1/10 and pause it. And you see there's just a single beacon here. So maybe I can take it a little bit faster so you can see what is happening. There, right. So that's easy enough. So you can measure this one, and yeah, of course, a beacon. So I'm using a 40 MHz channel with channel 5 as a secondary channel. So it's sending a beacon on channel 1 with the reduced neighbor report included. So that's fine, right? So now I can play this one again to see the beaconing, and then I'm just going to disable the one on the Cisco 98-100 controller, see it stops, and then I'm going to activate it on Meraki. So I'm going to enable. I have 3 SSIDs on this Meraki lab, and there's one access point, one 9166 access point, the same type of access point. And now, what do we see? I'm going to enable a non-preferred scanning channel on Meraki. So I'm going to see what happens. Takes a little bit while longer before it is synced, but you will see it will be activated pretty soon. So I also did like a capture of this there. I did a capture of this using the VLAN Pi, but now with Meraki using a non-preferred scanning channel, is sending a beacon on channel 1 and channel 5 at the exact same time. So if we pause this one, I can change the colors a little bit so you can see it a little bit clearer. Let's see, it's a little bit, the signal is a little bit weak. You can see here it is 100, that's a beacon. and you can see it here. There, you see there it stops. It's sending it at the exact same time. Like we have now a double beaconing from the access point because of the non-preferred scanning channel. Maybe this is something in their documentation, I don't know. But if I took a capture of this with the VLAN Pi, and I'm gonna just open up the Wireshark, and here we see the access point is sending a beacon on channel 1 and channel 5, and my Cisco access point is just sending on channel 1. But Meraki is sending us on both channels. But this is only happening when we're using non-preferred scanning channel. This particular SSID have 5 and 6 GHz enabled. And I have 2 other SSIDs I mentioned on config here, so it should be plenty of possibilities to include the network instead of sending 2 beacons. Pretty sure we can find this somewhere in the documentation. I just thought as this was a little bit weird, and it's great to have different tools using the MacBook with AirTool to be able to easily capture multiple channels, and having the Ronia RTSA Suite Pro or a real-time spectrum analyzer, so we can see exactly what is happening. So we can see this live and see if, for example, if it was the exact same time. It's extremely close. Like we saw, it's very hard to. Almost like. Very, very close, at least. But I thought it would just fun to share this. I can go a little bit back to Wireshark just if you didn't see it. You see the time between the 2 beacons. It's pretty close, but yeah. I thought that again, fun to share. And cool to just use all the cool tools that I have available to figure these things out. And now I need to go over all the Meraki documentation to find out why they do this and why Cisco doesn't. Because, again, just use reduced Neighbour Report. It works. Don't send beacons on every single channel. Got me thinking. Just to end off this short little video, if I enabled a wider channel, what will then happen? So let's see. So I can see a little bit. Let's say if I change, I can change to 40. You can't see the screen. I don't want to share my private Meraki instance. So what I'm going to do, and just going to change this, the 6 GHz to 80 megahertz. And then I'm going to press play on the spectrum analyzer. So you can't see the whole channel line. But in theory now, the Meraki access point should send a channel on 159. There, yes. Looks like it. Did it? It's all just a little bit. It's only a little bit of a flash, right? So hopefully it doesn't. Does it only send on the primary and one of the secondaries? I can move this a little bit to the right. Now maybe, since I wrongfully configured the 80 MHz on the 5 GHz radio instead. So let's see if it happens now, if we enable an 80 MHz on Meraki using a non-preferred scanning channel. Yeah, there we have it. So that meaning if I have a 160 MHz channel, it will send a freaking beacon on every single channel. Think how fun that will be by having broadcast probe response set every 5 milliseconds. That's just insane. Yeah, that's it. Take care. Just leave a comment if you think this was a good idea from Meraki side. I think it's a very confusing way to help clients find their 6 GHz network. Talk in the next one. Goodbye.